Question 5 deals with systems of linear equations. You are given a set of 3 equations with an unknown a in the third equation. And you're told a is a real number. If a is equal to 4, find the solution to the system. 2 marks is your first clue here, that we're probably not going to be doing a whole load of work. Your second clue is that you have a calculator sat next to you. So we take our GDC, we turn it on, we go into our menu, and we go into our equation solver, and we want simultaneous equations, 3 unknowns, x, y, and z, and we're just going to type in our variables. They've even been really nice and put them in the correct order for us. X, y, z equals constant, and that's what it says at the top to remind you. And we just enter our coefficients. So 1, 1, 2, 2, 2, negative 1, 3, 2, 5, negative 1, and then a, it tells you a is 4, and then 5. And then I just press solve, and it solves this for me, and we want our answers exact. So I have x is equal to 11 over 12, I have y is equal to, if I push down, 7 over 12, and I have z is equal to 1/4. Now it is entirely possible that you can do this by hand, but honestly, why would you bother? And if in the exam I wanted to check at the end this was working, I'd just sub these numbers back into these equations to check that they were consistent, and indeed they will be. Part B, find the value of a for which there exists a unique solution, and then a value of a for which there are no solutions at all. So both of those cases where I don't know what a is, but basically I'm checking to see whether these equations are consistent or are not. The way I would approach this is to perform Gaussian elimination using my matrix of coefficients, 1, 1, 2, 2, 2, negative 1, 3, 2, 5, negative 1, a, 5, until I get to a form that allows me to read off what a should be. In essence, my aim at the end of this is to get to 1, 1, 1, 0, 0, 0, and then some stuff I don't care about over here. I'm not going to get to a 1 here, I'm going to get to something in terms of a, but that's absolutely fine. And the way I would always approach this is first focus just on my first column, getting to 1, 0, 0. So I'm going to do row 2 becoming row 2, subtract 2 times row 1, so I get 2 subtract 2, giving me 0, and row 3 becoming row 3, subtract 5 row 1, so I get 5 subtract 5, giving me 0. So my first row remains unchanged. My second row, 2 subtract 2 is 0, negative 1 subtract 2 is negative 3, 3 subtract 4 is negative 1, 2 subtract 4 is negative 2. My third row, 5 subtract 5 is 0, negative 1 subtract 5 is negative 6, a subtract 10 is just a subtract 10, and 5 subtract 10 is negative 5. Now I'm noting some things here already about how exactly this is set up, but my next aim is just to, in essence, make this negative 6 into a 0. So I'm going to rewrite row 3 as row 3 subtract 2 times row 2. So I have negative 6 subtract negative 6, which is just 0. So 1, 1, 2, 2, 0, I should put my line there really, negative 3, negative 1, negative 2. First 2 rows aren't changed. And this is why I focused on column 1 first, because now 0 subtract 0 is 0. I've not ruined my first column. Negative 6 subtract negative 6 is 0. A subtract 10 subtract negative 2 is a subtract 8. And negative 5 and then subtract negative 4 is negative 1. Negative 1. And so, as I carry this out, and I look at this setup here, I'm looking for unique solutions, and I'm looking for no solutions at all. So no solutions at all means this is impossible. This is impossible. That would occur if I had 0, 0, 0, because then my equation would be 0x plus 0y plus 0z equals negative 1. 0 is equal to negative 1. That's not true. So the second part of this question occurs when a subtract 8 is equal to 0, because then I get 0 is negative 1. So that occurs when a is equal to 8. So there are no solutions at all when a is equal to 8. For any other setup here, if I have a is equal to, let's say, 4, as I had in the previous question, I'm going to get something z is equal to negative 1. That will always have a set of unique solutions. So it's possible that any value other than 8 is going to give me unique solutions. So my set of values is a is not equal to 8. The other thing we haven't considered here is infinite solutions. Infinite solutions would occur where something true occurs down here, but not useful. So if this was 0, 0, a subtract a, and then 0, then I could make 0 equals 0, which would be true but unhelpful, and that would be infinite solutions. Because this is -1, it's impossible to get infinite solutions, and therefore I can either have no solutions when a is 8, or any other situation when a is not equal to 8. And that's 8 marks in the exam sorted.